Hello, so this is Warren from Apollo Tech Support, and the final video in the IS series that we want to show you is the IS sounder circuit. So these are conventional IS certified sounders for use in hazardous areas. So the hazardous area might have a dangerous mixture of gases and chemicals that could cause an explosion if we get a spark from the electrical equipment. So the devices in there are specially approved so they won't spark or overheat, and we should have some sort of barrier on the circuit that stops any large power being drawn into the hazardous area and causing a spark or an overheating situation. So just to look at the IS sounder circuit, we don't do loop powered IS sounders or addressable IS sounders. So at the moment we have to look at a conventional sounder circuit. So what we have here is our loop tester, which is connected to a sounder control unit. So a sounder control unit DIM rail version, which is 55,182 these days. And the sounder circuit will require a power supply. So we've got a local power supply, which at the moment is being provided by my loop tester. And we've got an analog value of 16 on the sounder circuit, and only if we get a fault condition will that change. So it's gone, I've lost my local power supply, it's gone to analog value 4. And this is connected into a barrier, and it's a particular barrier from Pepperl & Fuchs which we use for the IS sounder circuit. So we've got our loop connections going into the sounder circuit, then we've got some connections going through the barrier. The blue side of the barrier, the blue connections go out to the IS sounders, and these are E2S IS sounders supplied by Klaxon Signals. We can't have too many sounders on this circuit because, as you can imagine, it's quite limited the power that we can have on the circuit. So usually it's only one sounder or one sounder beacon that we can use. In this particular case, I've managed to fit 2 devices onto the sounder circuit. And obviously we can operate these sounders if we get an alarm condition. So simply send the alarm. And obviously, because we've got an alarm going on, they're taking quite a bit of power. You can see that affects the loop quite a bit, which is why we don't usually recommend 2 devices on the sounder circuit. You can see the loop noise in the corner there, because I'm using the loop tester for my local power supply connection, goes absolutely crazy. And you can see some corrupt data being produced there. So we wouldn't obviously usually do that. This would normally be connected to a local power supply instead of into our loop tester. But so it's just to show you really that you can have an intrinsically safe sounder circuit, although it's slightly limited for what we can actually perform on that system. So so that's our IS sounder circuit.